Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about geometric sequences, specifically how they can be defined recursively and what they are. We also have 8 worked examples for you. If this is the first time you've been to my channel, welcome. I'm really happy you're here. If you're returning, thank you so much for coming back. If you enjoy what you see, please subscribe to the channel, give me a thumbs up, or leave a comment. Let's start. What is a geometric sequence? Well, it's a sequence where each term after the first is computed by multiplying the previous term by the same non-zero constant. That constant we call the common ratio of the sequence. So a sequence that's geometric will look kind of like this. The first term will just be whatever it is. We call it a sub 1. The second term will be a sub 1 multiplied by some constant, which is r here. The third term will be the same as the second term, but multiplied again by that same constant r. So now we've got 2 of them, so we get r squared. And that this process keeps going. So the fourth term has 3 r's multiplied by the first term, a sub 1. And it keeps going on forever. A finite geometric sequence stops at n, but an infinite geometric sequence keeps going on forever. The ratio, the common ratio r, you find by taking the second term, a sub 2, and dividing it by the first term, a sub 1. So we have a couple examples here. The first example, the first term is 1, the second term is 5, the third term is 25. If we want to find the ratio, the common ratio r, we take the second term, which is 5, divided by 1, the first term, and we get 5. So each term after the first is multiplied by 5. So 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125, and so on. The second example, the first term is 9, the second term is negative 3, so we can find the ratio. 3 divided by 9 gives me negative 1/3. So that means every term after the first is multiplied by negative 1/3. So 9 divided by negative 3 is negative 3. 3 multiplied by 1/3 gives us positive 1. 1 multiplied by 1/3 gives us, or by negative 1/3 gives us negative 1/3, and so on. So if the ratio is negative, then you'll see an alternating sign, positive, negative, and so on. And just a note, a geometric sequence with the common ratio r bigger than 0, but not equal to 1, is an exponential function whose domain is a set of all positive integers. Write the first 4 terms of each geometric sequence. We've got 3 examples here. The first geometric sequence we get, the first term is 12. We can see that it's given to us here, and the common ratio is 1/2. So we can use both of those. Let's write the first term just as it's given to us. The second term is the first term multiplied by the common ratio, which is 1/2. 12 times 1/2 is 6. Then the third term is the second term. We just keep multiplying by 1/2, right? So we have 6 times 1/2, which is 3. And the fourth term, 3 multiplied by 1/2, is 3/2. So our answers then are, the first 4 terms of the sequence would be 12, 6, 3, 3/2, and it keeps going, but we're only writing down the first 4. Let's do the second one. The second example, a sub 1 is 5, so that's where we start. And the common ratio is negative 3, so to get the second term, we'll multiply by negative 3, so we get negative 15. Negative 15 times negative 3. Maybe I should write that out here so you can see. Gives me positive 45. And then we have positive 45 times negative 3, which gives us negative 135. Can't quite see that other end of the screen. So we can write down our sequence, well, the first 4 terms of the sequence as 5, negative 15, 45, and negative 135. And of course, there are more terms, an infinite number of them, but we are only writing down the first 4. Let's do the last example here. The first term is 5/2 because it's given to us. The common ratio is negative 1/2, so that means to get the second term, take 5/2, we multiply by negative 1/2. That gives us negative 5/4. We take that negative 5/4, multiply again by negative 1/2 to get our third term, and we get a positive 5/8. We take that 5/8, multiply by negative 1/2 to get our fourth term, which is negative 5/16. So we can write down the first 4 terms as 5/2, negative 5/4, 5/8, and negative 5/16. And of course there are more, but we're just writing down the first 4. This kind of helps us see a pattern that we can define a geometric series, or sequence by using a recursive formula. And the recursive formula is you take the previous term, you multiply it by r, and that gives you the next term. Or if you want to say it the other way around, any given term, a sub n, as long as n is 2 or bigger, you can find by taking the previous term and multiplying by r. So again, all we need to write the whole sequence is the first term, a sub 1, and the common ratio, r. Let's find the first 4 terms of this geometric sequence. And this time we're given the recursion formula for each of them. We write down our first term, 10, and notice we multiply by 4 to get our next term here. So negative 4 times 10 gives me negative 40. Then negative 40 times negative 4 gives me 160. And then 160 multiplied by negative 4 gives me 640. So I can write down the first 4 terms here. 10, negative 40, 160, and 640. Negative 640. We can't forget that negative in there. There's a negative. You just can't see it. All right, and of course there are more terms, but we are not writing them. We're just writing the first 4. Let's look at B. So we look at B, the first term, a sub 1, is given to us as negative 6. And we can see that negative 5 is the common ratio. So negative 6 times negative 5 gives us 30. And then we have 30 times negative 5 gives us negative 150. And negative 150 times negative 5 gives us 750. So we can write down the first 4 terms as negative 6, 30, negative 150, and 750. And there are more, but we're not writing them. The last one, our first term is 3/2. And our common ratio is 1/3. So 3/2 times 1/3. This is kind of nice because 3's cancel. And we're left with 1/2. And so we take 1/2 to find the next term and multiply by 1/3. And that gives us 1/6. And then we take 1/6 and multiply by 1/3 and get 1/18. So we can write out the first 4 terms as 3 halves, 1/2, 1/6, and 1/18. And there are more, but we are only writing down the first 4. That's it. Hope that was helpful, and hope you have a great day. Thanks for watching.